All right, so we're gonna make a bridge that spans 20 inches and it has to be a max of 22 inches long. It's gotta support 100 pounds and have a strength to weight ratio of 250 to be successful. It can only be 8 inches wide, and for the roadway it needs to be 1/16 inches thick at least, and it needs to have like a 4x4 section for the traffic to go through.
Our materials is that we get 6 pieces of wood with these dimensions, 10 pieces with these dimensions, and then 14 of this dimension, and then 1 sheet that's this big. And we also get a plate that's 4 inches by 6 inches where the weight will be suspended from.
All right, so here's some of our concepts. So here we've got a truss bridge, but we've kind of incorporated a little bit of an arch to it as well. Yeah, that's that one.
And then here's how we think the joints are gonna look that we brainstormed. We're gonna cut them at angles just so that they fit together better. And then this is another truss bridge design that we thought is more simple. And it's just a concept we're considering.
All right, so for our 2 ideas that we originally had, we had the arch and we had the straight truss. The arch we really liked because it was a good way to do both an arch bridge and also a truss bridge at the same time. But it was just kind of seemed too complicated to figure out all the angles for those and to cut them consistently.
So we decided to go with this bridge without the arch in it. It was mainly because, yeah, like you said, it would be less complicated with all the angles, and we'd be able to have evenly spaced out trusses and just be able to measure that easier.
So right now I am just sanding down our truss beams to size based off of the scale drawing that I made over here.
And then I'm making cross beams for the base of the bridge that'll support the floor by just gluing 2 of these together.
All right, so here is our finished bridge. We decided to go with a straight truss design right there. Now we've got, we got some glue drawings. We're gonna set on inside. So we got this truss, just a simple truss there, into some reinforcements, just kind of transfer load across into these beams, especially in this middle section right here, just transfer that load up. We got these beams right here, which are gonna take this load pulling down here and transfer them in tension into this spot right here, which will hopefully transfer that to those spots. So on the bottom, we've got just a little bit of reinforcements there, and that's kind of our base design. We got these cross sections and these beams going across, including these beams right here, which are currently drying, to hopefully just beefing up this joint right here where most of the weight's gonna be.
We also have our gusset plates on all the joints here, just trying to keep the bridge all together at the joints, make sure they're strong there. Then at the top, we added some reinforcements just to hold the bridge together as a whole and hold like the top together. These beams going across. We added a beam diagonally, just trying to keep the bridge straight so that it doesn't twist when it has stress on it. And that's pretty much it for our final design.
That middle beam, disconnected. That gusset plate, that
Our final results were that the bridge held 196 pounds. This exceeded our expectations. because we weren't sure about our craftsmanship. The gusset plates were a really good idea that held our joints together and compensated for any weak joints, and that was the reason that our bridge did so well.
In the future, we'd probably improve our bridge by sanding down the joints that the gusset plate sat on, as that's what broke in the end was a gusset plate cracked because the two things we glued it to weren't exactly flush. And once that gusset plate broke, that joint came apart, and the whole rest of the bridge kind of fell apart from there.